Okay, so 17G is the geometric interpretation of the integral. And so you guys, the geometric interpretation of the integral. So some of you already know, you've heard that the integral is the area under the curve. And that works for, as long as the curve is above the x-axis, you can see this, for example, the integral from 2 to 6 of x squared plus 2 dx. That is going to be the area under the curve. And so, I can draw the graph. It's a parabola. The y-intercept is 2, it's a smile, and the idea is from 2 to 6, what math can do for you, the integral, is that you can find the area of that really weird-looking shape. It's not a trapezoid, it's not a rectangle, but you can use math to find that. And so, from chapter 17F, we take the integral, so it's x cubed over 3 plus 2x. We don't need the c anymore, it's from 2 to 6. And you learn from chapter 17F, once you take the integral, you substitute the 6 into the first term, 6 cubed over 3 plus 2 times 2. And you subtract off after substituting 2 into the term. So it's 2 to the third over 3 minus 2 times 3. You do the math with your calculator or by hand. What do we have here? 216 over 3 plus 4 minus 8 over 3 plus 6. Okay? Right? Oh, no, sorry. This is plus, this is minus.
It's plus 2 times 6 for the first one, isn't it?
Correct. Sorry. Perfect. And that's good? No. Okay, so we have, 208 over 3 plus 24 over 3, and that gives us what? Yeah. 208, sorry. What's the answer? Anyone? 184.3, which is approximately 61 1/3. And so that's kind of cool, right? Because the area of this space, whether it's inches or centimeters or meters, it's 61 1/3. And so you're like, this is great. Now I can find the area between a curve and the x-axis. But we start to have a little weird things start to happen. So when you see in the book, this exercise, the integral from 0 to 4 of x squared minus 2x minus 3 dx, and you go through the motions, you're thinking you're going to find the area. You have, x cubed over 3 minus x squared minus 3x from 4 to 0, and you say, I'm in luck because the 4 goes in here, and the 0 is just going to cancel everything out. And you plug it in, right? And we get what? 64 over 3 minus, what's 4 squared?
16.
So it becomes 48 over 3. And what's 4 times 3?
12.
So we get 36 over 3, and we end up with what? 84 minus 14. Right? So we get this weird answer. We get like a negative number. And you say, well, how do we have a negative area? We'll talk about it in a second. Or we get something even weirder when I ask you to find the integral from 0 to 2 pi of sine of x. and you say, I know there's area under that curve. I know what the sine wave looks like, so I know there's area under the curve. What is the integral of sine of x? Anyone? What's the derivative of sine?
Minus cos x.
So the answer is negative cosine x. From 0 to 2 pi. What is the cosine of negative, what is the cosine of 2 pi? This is a part of the question. What is the cosine of 2 pi?
1.
So it's negative 1 minus, and what is the cosine of 0?
1.
So what is negative 1 minus negative 1?
0.
0. So we have a problem. We have to figure out why what we thought area under the curve is giving us these weird answers, why it's giving us negative numbers, and why this is giving us 0. So we need to go back and we need to do a little theory. Okay? We need to do a little theory. And we're gonna go with this. We're gonna go with this integral. So the first diagram I'm going to ask you to do, well, I'm going to ask you in your notebook to draw a graph, right? And the first diagram is going to look something like this. It's going to be 2 to 6. And for y equals x squared plus 2. And I'm going to ask you to have 2 colors, a red and hopefully a green that works. Unfortunately, my markers don't work, so you're going to have to bear with me. So how do we find we want to find the area under the curve. Any suggestions? Exactly. We can put rectangles in there. So I'm going to start at 2, and I'm going to call this my lower limit. I'm going to start with my lower limit, and I'm going to put in a rectangle here. And the other thing I could do is start at 6 and put a upper limit or upper rectangle here, right? Because I'm looking for this area. So can someone figure out what is the area of that green rectangle? Anyone? Well, what's
16.
What's the length of the base of both rectangles?
4.
4. What's the height of the green rectangle?
6.
I'm sorry?
6.
6. Yeah, because this is 6, right?
Oh, plus 2, okay.
Plus 2. I totally forgot that also. And what's the height of the red?
38.
38. Okay, so what is the area of the green rectangle?
24.
24. And what is the area of the red rectangle?
228.
I'm sorry?
228. Actually, no. 152.
152. What was the area? What was the answer to this question, by the way?
232 over 3.
I'm sorry, once again?
232 over 3.
No. I thought it was 60. I thought it was like 61 and a third, right?
You subtracted instead of adding?
So what was the final answer? Okay, I was wrong. So it's 70.
1. Wait. 77.7.
Okay, it's this.
77.3.
77.3. Okay, so we're getting close. What can we do better from that? So that's good, but we can do better, right? What can we do in my next diagram? So I'm going to draw another diagram. What can I do better? What can I do better? Any suggestions?
Make the rectangle smaller.
So let's make it a little smaller. What should I do here? Let me put a 4 in here, right? So let's start with the lower limit. So we're going to start 2. And we're going to make this rectangle here 4. And I'm going to start from the 4 and start at the 6. Okay, we're getting better, right? So what's the length of the bases of all the rectangles?
2.
Yeah, we went from 4, now we're going to 2. What's the height of the left green one?
6. Wait.
Yeah. It's still 6, right? What's the height of the second green rectangle?
18.
Okay, so what's the area of the small green?
12.
And what's the area of the
36.
36? Now let's work on the red rectangles. What's the area of the red?
36.
This is 36. What's going on over here?
76.
76, right? Because the length is 2 and the height is still our 152. Our height is still 38. 38 times 2 is 76. Okay, so what's the lower sum? So the lower sum is 12 plus 36. What is that?
48.
Good. And what's the upper sum?
112.
112. What's going on here? Are we getting closer? Yeah, I don't know. Devo, are we getting closer?
I'm not sure.
What do you mean you're not sure?
I'm kind of lost.
Where are you lost?
What number are we trying to get close to?
This. Because we solved this, right?
Yeah.
Integration told us what the area is going to be. But we need to figure it out. But we thought, yeah, right? We know the answer is 77.3. Right?
Yeah.
So are we getting closer to 77.3?
Yes.
Yeah, it's in the middle here. We just have to figure out what to get there. Well, what else can we do? Can we do something else? What else can we do? This is great, 112 and 48. What time is it? Okay. Yeah, I have 20 minutes to talk. Let's keep going. Who hasn't spoken? Sinan, what's the next thing we can do?
Make it even smaller.
Make it even smaller. Can I erase this first one? Can I erase this?
Yeah.
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 Okay. Let's make it even smaller. Let's make it even smaller. Like my graph. Here's 2. My partition went to 2. Now it goes to 4. Right? 2, 3, 4, 5, 6. What's my delta x now? I'm sorry, what's my dx? No, I apologize. What's my delta x now?
1.
1, right? So, let's figure this out. What is the lower rectangle here?
6.
6. 6 times 1 is 6. What's my lower rectangle here?
$11.
Nice. What's my lower rectangle here?
18.
18,
18. What's my lower rectangle here?
22,
Sorry,
27.
27. Hey Siri, 6 plus 11 plus 18 plus 27.
6 plus 11 plus 18 plus 27 is 62.
Nice. Let's do the upper one. What's the upper? So what's this first upper rectangle?
11.
11. What's the next upper rectangle? 18. What's the next?
27.
What's the next one?
38.
38. Hey Siri. 11 plus 18 plus 27 plus 38.
11 plus 18 plus 27 plus 38 is 94.
94. Are we even closer to where we want to be?
Yes.
Yeah. So, am I going to do another one? Am I doing this again or no? Am I doing this again or no?
No.
No. So, what's theoretically happening? What is theoretically happening?
The upper and lower limit are getting closer and approaching 77.3.
No, but what's the it that's getting closer? Well, yeah. I'm sorry. Yeah. So the question is, what are we not going to do again? But what are we theoretically going to do?
The size of the rectangles are approaching 0.
Very good. Where have you seen that before? Where have you seen that before? The limits approaching 0. Well, that was with the derivative. So the idea is we are going to create from A to B an infinity of partitions. So create an infinity so the idea is it's the delta x is approaching 0. That's the idea. So we have an infinity of rectangles, right? So first things first. So what did we do? What did we do for these answers? We added up the rectangles, right? So we added the areas of the rectangles. Question, how did we find the area of a rectangle? Can everyone see down here? Can everyone see that?
Yeah.
Yes,
Yeah.
Renuma, how did we find the area of a rectangle?
Del x times del
So we had delta x, right? So it was delta x, and what was the height of the rectangle?
y. X squared plus 3.
No. How did we find, in general though, so how did you get like h squared? How did you get that? What was the height? What did it depend on?
It depended on the x.
On the function, right?
Yeah.
It depended on whatever function. And then, so the area is f of x times, now here's the thing, as delta x goes to 0, we're going to call this dx. That's the difference. Delta x is like from your slope days, dx is when delta x approaches 0, right? So this is the area of any rectangle, and therefore, right? And we started from A, and we ended at B. What's a fancy word for addition? What is the fancy word for addition? Is anyone there? Hello?
Combining?
No, starts with that. What's the fancy word for addition? Dabo? Renuma?
Summation.
Yeah, what's the first letter of sum?
Yes.
You mad? So the integral, when you see this, this means the sum of the areas of the rectangles from A to B. Now, why did I need to go through all this? Because what value could f of x take? That's my question to you. What value could f of x take? Unsuck.
Yeah.
What value could f of x take? Is f of x always going to be positive?
Not always.
Not always, right? And so could f of x be a negative number?
Yeah.
Yeah, could it be 0?
Yeah.
Yeah, so we have to be careful when you say, oh, that's the area under the curve. No, you have to say to yourself, that is the area of that is the sum of the rectangles. So let's just go back, right? And let's just review the last question. What's going on with my picture? Y equals x squared minus 2x minus 3. First of all, how do I sketch this graph? So quickly, let's see, who's going to tell us the answer? Let's see, Sinan is going to tell us what the zeros are of this parabola.
Oh, sorry, I was muted. The zeros are -1, x is equal to -1, and x is equal to 3.
Good. So we have 3 and -1. So my parabola looks something like this, right? Now, in that original question, I asked you to go from 0 to 4. I asked you to find the area from 0 to 4. So what's the problem? What's the issue? Let's not call it a problem. What's the issue? Why are we getting negative numbers for this answer? Chang, why would this give us negative numbers?
The graph is under the x-axis.
Yeah, so we're technically going to get some negative areas. We know from geometry, what does negative numbers mean in geometry? Hey, Chan.
Negative numbers mean that it is below.
Yeah, exactly. It just means below. It doesn't mean like an area of negatives. You know what I'm saying? It doesn't mean less than 0. It just means, oh, you're going to have some numbers below the axis. And we saw that's going to be a problem because is there more underneath than above? Yeah, so that's where the negative number comes from. Any suggestions in our calculator or any let's see, Renuma, do you have any suggestions of what we might have to do to avoid getting a negative number?
Just take the changes
So you're saying find out when it's below the axis and when it's above the axis and split it up.
Yeah.
So you're saying first find the integral from 0 to 3.
And
Okay.
then add from like 3.
And then do what?
And then add the integral from 3 to 4.
Yeah, something like that. Now this was more old school. But this is the idea. You have to be aware that you have to be aware if there's parts of the curve underneath the x-axis, you're gonna get like negative areas. And so that's gonna undo your positive areas. Let's take a look at sine of x. What's going on over, can everyone see me over here? What's going on with my curve? Can everyone see why I'm going to get 0 for the area?
Yeah, because you're gonna have it.
Yeah. Let's see. Who haven't spoken? Asina. Chang. Chang. Why is this clear to you that we're getting 0 for the area under the curve?
The area above the x-axis and below the x-axis are equal, so they cancel each other out.
Yeah. So once again, be careful of this area. And the area of A is equal to the area of B. So once again, I'm just going to conclude, because that's the point I'm trying to make. This does not automatically mean area under the curve. It means the sum of the rectangles from A to B. You have to be careful. I think that's all I want to talk about. So the books, whenever you have a curve, so the point is when you're taking the integral, I think with chapter 17, I think with 17G, 17G, they didn't even ask you to think about it. They just asked you to do the mechanics. But 17H asks you to actually look at the curve and really think about what part is above, what part is below. And that's basically it. That's it. So 17, what is 17G? So let me shut this off, stop sharing.